Hello again. I will begin the second video by making the tailstock and tool rest, which you can see in this 3D model. First, I'll cut and glue these pieces for the tailstock. Just like before, I'll use a pair of screws in addition to glue. Now I sand the edges. The third piece will only be screwed in so that it can be removed later. I machine the base and screw it to the three pieces. I'll mark the center to drill a hole with the threaded rod itself. It seems to match the template quite well. I drill a hole in it and press fit this coupling nut. Now I make a hole in the third piece using a bit with the same diameter as the threaded rod. At this point I can glue the three pieces. I machine and screw in these reinforcements. I attach the handle, which I've drilled with a bit with 1 mm less diameter than the threaded rod. Now I machine the pieces for the tool rest and glue them together like before. With a 3D router, I machine this fitting groove. I make a hole here to insert a piece of threaded rod that will allow me to adjust the height of the tool rest. The bit must be 1 mm less than the rod so that it will fit in. Here, I make holes with a bit of the same diameter as the rod. After machining all the tool rest pieces, I cut and glue these pieces of P120 sandpaper with contact adhesive. This will help us lock the two accessories at the desired position. I've prepared all the knobs. You can see how to make them in this other video. I've also installed the switches and an emergency lock. I use this model I had in my workshop, but if you have to buy one, I recommend using one of this type. It's cheaper, easier to install, and more compact. Now I put the motor in place. I'll use these hinges to make it turn. I'll use another coupling nut to make the drive center. I mark it like this and cut it with a hacksaw. Now I'll make a bevel with the angle grinder to sharpen the tips. I finished the job with a file and a Dremel. I drill and countersink this piece of aluminium to protect the tool rest. And finally, I'll do a little test with a piece of ash wood. After marking the centers, I put it in place, tighten all the knobs, and adjust the tool rest's height. Since it's not a wide piece, I'll select the pulley combination with the most revolutions per minute. Seems everything is working as it should. It runs smoothly, without vibrations, and the drive center isn't slipping off. Some of you have asked me about the motor. It's a single-stage 1 HP motor with 1500 revolutions per minute. Using this pulley configuration, I obtain 3 speeds, 800 revolutions per minute for pieces with a wider diameter, 1500 revolutions per minute, and the fastest speed, 2800 revolutions per minute, which I'm using here. It's within the usual range of speeds for lathing wood. That's all for today. In the next video, I'll prepare the disc sander. See you soon!